Today we will first talk about our clustering thing, which we did last time on this topic. And today we will see how clustering works. So you must be seeing a photo on your screen, which you can see that there are some faces of some people are visible. These are some faces like if we mark that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The faces or the data will must be some little bit blurred, I know, because I have just taken this image from the Google, and this is not a HD image. This is just an example to explain you what is clustering. Also, Piyush is not present in our last session, I think. So it will also help Piyush to clear this thing, what is clustering and how we will do that. Okay. So you can see there are some faces and there are some type of data we have like case. If we are talking about case 1, 2, 3, 4 to 12, this is the first, second, third. This is the case number. Sex, male or female, gender. You can say also glasses. They have wearing a glasses or not. Mustache. They have mustache or not. Smile. So you can see there are some type of data according to the faces or according to the people, you can say. Now what is our data on this? As you can see on your screen, some values are given here, like people's age, their sex, whatever they have mustache or not. The age is not here, only sex, glasses, mustache, smile and hat are there. Whether he is smiling or not, whether he is wearing a glasses or cap or not. So some such data is given here. Now we have to see according to this data what the similarities are between them. In a last session, Ali, if you remember, we have discussed about when we had discussed about hierarchical clustering. I have told you we have to focus on three things. What
Actually,
are these three things? Can you repeat?
patterns, similarities,
Yeah,
and differences.
patterns, similarities, and differences, right?
Yes.
So what we have to do here in a clustering, we have to cluster these faces. We have to make different clusters here. So what we have to do is, when we talked about clustering, we had talked about the similarities between different things, the differences between the values or data. And if we follow our patterns, then there will be some similarities in these people. You can say if we have 12 faces here, right? So what we can say as similarities, if we let me check. Okay, if we focus on 1 and 7, okay, this one and this one. So what we can see in data also, both are males, 1 and 7, both are males, right? Glasses, they are wearing glasses, true. Mustache, they both have mustache or not?
Not
Not, okay. False. Smiling or not?
right.
Right,
I
true. They are
see.
smiling.
Yes.
They have hat?
Yes.
No. So we can say that they have some similarities, right?
Right.
So they can be pair up on a cluster. This is our one cluster. If we want to check other clusters also, 5 and 11, I guess. Let me check. Both are males. Both are not wearing glasses. Both have, both don't have mustache, right? They
Right.
are smiling. Both are smiling. And
Yes.
they are not, they are, one is wearing a hat and another one is not. But if we are
Right.
talking about similarities, they have similarities. They have four same similarities. So we can say that we can also make a cluster of them. So this is the perfect example sorry, of how clustering works, right?
Yeah.
So Piyush, this is clustering what we have talked about in our last session. You will get the recording, I hope. So clustering is a basic thing when we are working on a data. We have to follow some rules like we are discussing right now, hierarchical clustering. And today we are gonna continue with the topic of which type of techniques we are gonna work on in the clustering. So is this thing clear to you guys?
Yes.
Okay. So now we talked about clustering, right? So now we are gonna discuss about some techniques we use in our hierarchical clustering. Hierarchical clustering. Guys, are you taking the notes?
Yes.
Because we are gonna discuss about some important topics today. So, so our first technique we are gonna talk about is agglomerative clustering. Agglo, A double G, L O M E R, agglomerative clustering. This is the heading. Agglomerative clustering. Now, if you are talking about this, what is that? Let me explain it to you guys. If I'll try to explain it to you, then you people will know what are records, right? We have talked about records, Ali, right? Do you remember
Yeah.
what are
Yes.
records? These are some records. So if I'll explain in a shorter to Piyush what is records. Suppose you have a record of clustering set, and a record is a set in which a set has been made on the basis of similarities or differences, and we call them records. This is the simplest definition I can tell you. Records are the set or subset made based on the similarities on or differences. So you can say these are some cluster records. Okay, so let's assume that we have some records A, B, C, D, E, F. So we have 6 records now. And how do we do the next three clustering law? Now we are look at the distance between these records. What is agglomerative clustering is we have to calculate or check the distance between A to B, A to C, A to D, A to E, and then A to F. Okay, then B to C, B to D, B to E, and then B to F. Then C to D, C to E, C to F, then D to E, D to F, then E to F. Now, so we have understood until now that we are looking at the distance between all the records. Now, after looking at the distance, what will we do is, but whatever distance is gonna comes to us, the minimum, the shortest distance we are gonna focusing on in algorithm clustering. So you can say which records or which one of the record will be the closest closest one. Okay, then what will we do? We will make it one. For example, you can see here if we are assuming E to F is the shortest one, right? If we can say E to F is the shortest one. So now what we are doing, we create we can join this both records into a one, and it will make as A, B, C, D, E, and F. This will become one. Now what we have to do is we have to again calculate the distance between A to B, A to C, A to D, and A to E, F, and so on, B to C, B to D, and so on, you can say, right? Now we have to check again what is the distance between these records are. Which one is the shortest or which one is the closest one? Then we have to also create a new record by that. So first of all, guys, this is the theory thing. In a Python, we just have to do, sorry, we just have to focus on our commands. But for a knowledge, I am telling you this theory because sometimes in an interview, company manager or someone who is taking your interview will ask about algorithmic clustering and our dimensive, divisive clustering. What is agglomerative clustering, what is divisive clustering, and difference between them. That's why I'm telling you all of these topics for your knowledge. Now we have created this, right? Now we are again gonna see which one is closest. So after all, in the next step, you can say A, P, and third one will become C, D, E, F. Then now A, B, C, D, E, F. And in a final step, it will become one, A, B, C, D, E, F. It will become a single record. Okay. So what you have seen here, until all our records are connected to each other in a such way that their distance is increasing in a manner, then you can understand it directly, or you can understand a definition of algorithmic clustering, in which we have to see the distance, or you can say check the distance, or try to connect the two different records into a one based on their shortest shortest distance. There is work between the records, and according to those records, they have to be added together. And now the question is how we are gonna calculate the distance, and how what we have to do. So this thing we will discuss in our practical part when we are working, hands-on working on Python. Now that you understand what algorithmic clustering is, do you have any doubts? Ali, Piyush, what is algorithmic clustering? Do you have any doubts
Okay.
related to that?
No, added together, shortest distance.
This is very simple. If we have
Yes.
different records, we have to just check the distance between each and every record, and
Yes.
with the help of that, we have to add some different records into a one. Now we have talked about our algorithmic clustering. Our next topic is the second one, divisive clustering. Divisive clustering. Now, so our next topic is diversive clustering. Now, if I want to explain it to you in the most simplest way, then you should understand the thing or the steps we are talking about, our aggluterative clustering. In a divisive clustering, we have to do the same thing, but in a different manner. In a agglomerative clustering, we are trying to see or check the closest distance, right? In a divisive clustering, we have to check the maximum distance here. For example, but here this is the basic difference between agglomerative clustering and divisive clustering. When we are talking about our agglomerative clustering, we have a different records A, B, C, or D, right? But if we are talking about our divisive clustering, we have only a single record like A, B, C, D, E, F. So this is a single record here. Now in a divisive clustering, we have to check the distance of each of the record here and which one is the farthest one or maximum one. We have to remove them one by one. Like example, this is if this is the first step, so you can say A, B, C, D, E, and F is now removed. So one by one, every each of one record will gonna separate, and it will become like the first one A, B, C, D, E, and F. So this is the difference between agglomerative clustering and divisive clustering. So if I tell you in a theory matter, then you should understand the thing or the steps we are taking in a agglomerative clustering. We do the reverse of that. What we are doing here, we have to reverse the steps in divisive clustering. And this is the simple difference between them. Is this thing clear? What we have to do in divisive clustering and agglomerative clustering, and what is the difference?
Different, uh, traversing, same things, but I think argumentative is different, connects between different.
See, some things they also have some similarities, you can say. In agglomerative clustering, we are trying to check the see the distance is the factor here. We have to check the distance in both of the clustering or any of the clustering. If we are talking about clustering or try to use any of these techniques, we have to focus on our distance. So in agglomerative clustering, we are trying to focus on the closest one, which one is the minimal. And in a divisive clustering, we are focusing on the farthest one. But the difference is in a agglomerative clustering, we have different records A, B, C, and D. And in divisive clustering, we have only a single record A, B, C, D, and we have to separate them. So here we have to connect them into a one record, and here we have to separate them into different, right? So you can note that for your knowledge or something like that to revise what is the basic difference. also also we call them by some names like Agnes. These are the terms used by data scientists. Divisive clustering is famous by the name Diana. Okay. So our interviewer will also ask what is Agnes and what is Diana and what are the differences between them. Right. And both of these clusterings are most important in hierarchical clustering. If we are talking about our hierarchical clustering, these both techniques are most famous or mostly used. But there are more techniques like that. I'm not gonna tell you that there are only two techniques. There are many techniques for that. But if we are talking about most famous one or most used ones, these both are most famous and used. But I have little bit knowledge about some more uh, techniques, I'm gonna tell you the name like birch. You can note that birch, birch, and the full form of birch is balanced. Sorry. Balanced. Piyush, if you have any doubt, you can also ask that in our group, or you have to ask something. Balanced, iterative, reducing, and clustering using hierarchies. Hierarchies. What you are typing, Ali?
No, not typing.
You're not typing. Your keyboard sound is coming from your mic.
I say noise. Okay, let's me turn off the noise.
But what you are searching for?
Not saying.
Fourth one is cure. Our fourth technique is cure. And the full form is of cure is, let me remind,
With the noise?
cure.
No, no.
Cure.
Okay. No, my my mic has noise
Sorry.
or not?
Hello.
Okay.
Your voice is not coming properly. Can you type in the chat or group somewhere? I think your voice is breaking. Diversive clustering. Okay. Have you got the point of agglomerative clustering? What is agglomerative? What we do in a Agnes? Piyush? Can you reply me in a group or somewhere? Is first one clear to you? Agglomerative clustering. What is agglomerative? So you can understand by first one what we are doing in. I understood the first one. So what we are doing in our agglomerative clustering, we are focusing on different records and try to make them into a one with the help of step like focusing on their distance and try to connect one by one by focusing on their closest one distance, right? But if we are talking about our diversive clustering or Diana, I can say, we have only single record. I'm typing this here. We have a record by name, so you can assume A, B, C, D, right? So we have to do a clustering here and make them a final product as a final record as A, B, C, and D. We have to separate them one by one with the help of distancing again. But here we are focusing on the first one, we are focusing on the shortest one, but here we are trying to focusing on the maximum one. Which one is the farthest? Like if we are talking about here, A to D is the farthest. So what we do is first in a first step we separate D. Then we will receive A, B, C in a record and D is separated now. D is separated now. Again, we check the distance. Now A to C is farthest for assume. Okay, because we don't have any values here. So we are just assuming in a Python, when we have hundreds of values, we have to check them by with the help of our hierarchical clustering. So I am just giving you guys an example. We have to focus on our farthest one in a divisive clustering and shortest one in a agglomerative clustering. So now is this thing clear to you, Piyush? What is the difference and what is divisive clustering? So this is the basic difference. I hope this thing is cleared. This will clear more or more when we are doing it as a practical on a Python. Okay. So I have told you some more clustering techniques like Birch. You can note that balanced, iterative, reducing and clustering using hierarchies, right? Also, cure is clustering using representatives. Clustering using representatives. T-A-T-I-V-E-S. And one more clustering technique I have discussed in a single another batch, that is chameleon. Chameleon. I might pronounce this wrong, but the spelling is Chameleon. Chameleon, something like that. This is also a clustering name, but I don't know the full form of this, or I do not mind we remember, I think. So these are some clustering techniques, but we just have to focus on these two as we are the beginners. We are not gonna work on Google or Microsoft in a beginner level. So when we have to do some advanced things on AI or something like that, then we will use these types of clustering methods. For now, as a data scientist, we only have to focus on agglomerative clustering and divisive clustering. Is this thing clear to you guys? Have you noted that? So, we have talked about distance there, right? I have told you we have to focus on distance. Now, the thing is why and how we are gonna take a help of distance in our clustering. First thing is clear that we have to focus on similarities, differences, and patterns. But to do clustering, we also have to take help of distance. Now, if we are talking about properties of distance, properties of distance, so I can tell you, let's assume this is the distance, right? We have, when we are talking about distance, so let's assume this is the distance d. We are as like narrating distance as d. This point is called as I and this is j, right? I and j. So we can say that dij is equals to distance between, please keep on taking the notes guys, these are very important topics when we are talking about our data science thing. Now we are gonna like take a step on into advanced things like hierarchical clustering, machine learning, models, and so on. I and J. I'm just noting this J here. So you can say Dij is equals to distance between two records I and J. These are the records. and we have to calculate d here, what we do in Python. But there are some properties also, like first one is non-negative. And guys, in these topics, I know you guys have some doubts. So you can ask me anytime to take help. Dij is greater than 0. What we are saying, non-negative. First property is non-negative. Where we are saying Dij is always greater than 0. So is this thing clear? Why? Because you know why Dij is always greater than 0. Because if we are talking about two different records, you can see here. If we are talking about two different records from point I to point J, they have some distance, right? They have some distance. That's why we are saying Dij is non-negative, because Dij is always greater than 0. Is this thing clear? First one is clear to you why I am saying this? Why Dij is non-negative? Dij not cleared. That, that means you are asking what is Dij. See, when we are talking about distance, we are denoting distance as d. Distance is equals to d. First record or any record where a record will start. So we are saying first record is denoting by I. Second record is denoting by J. Third record is denoting by K, and so on. Fourth one is denoting by L, and so on. Okay. So here you can see if we have to calculate the distance between two different records, for example I and J. That's why I have told you Dij is equals to distance between two records I and J. The first property we have is non-negative. That means Dij is always greater than 0. So now are you clear what is Dij? Dij is a denoting point. When we are talking about formulas or something like that, we have to denote something with the help of a letter or something like that. Let's assume we have some records, right? And whenever we talk about data science, I have told you earlier, guys, that whenever we are trying to calculate something, we start with 0, 1, 2, 3, and 4 in a data science. In a data science, 0 matters to us, right? It matters. So we have also -1, -2, and -3 and -4. When we are talking about non-negative, if we have two different records, you can assume this one is first record and this one is second record, right? Record have some values, this record have some values. What values? Like based on similarities, patterns, and differences. They both have some similarities and they both have some differences. So between them, we have a distance d, right? And if we denote these both records with the help of I and j, if they are not same, they are not in a single record like I and j. If we are talking about I and j, then it does not have any distance, right? Because they are the same record. But there we can see that they are both different records. That means they have some distance. You can say if we are talking about a minimum 0.1, at least they have the distance of 0.1, right, Piyush? Because if 2 points have a distance, we cannot say that it is equals to 0, right? That's why we are seeing here Dij is always greater than 0. Because if we have two different records, we cannot say their distance between them, the distance between them is equals to 0. That is always greater to 0. Now this thing cleared why we are talking about properties, and we the first property is non-negative, and also why the name is non-negative. You are seeing here, when 2 points have some distance, it cannot be in negative. If a person, like you can say, is sitting here and the next person is sitting on another chair, and we have to check the distance between them, can we say that the distance is minus 1.2 meters? Can we say that? So now are you cleared about what is non-negative? So I assume you have noted this. So I am removing some part of this, and let's focus on our next property. So the first one is non-negative, and the second one is, you can say, dii is equals to 0. Now I have told you that if we are talking about two different points or two different records, they have some distance. But if we try to calculate the distance between a same record, if the record A is present and B is present, and someone asks that what is the distance between A to A, right? So that distance is dii is equals to 0. That means A have do not have any distance. It is 0. Because it is a single record, it is a single point. How we can, like calculate the distance bit, like into a single record? That's why we are saying dii is equals to 0. Okay. And our third property is symmetry. Symmetry, that is dij is equals to dji. It is also possible that if we are talking about two different records and they have some distance, if we try to calculate the distance from I to j, that is some number, let's assume x. And if we try to calculate the distance from j to I, let's reverse that. So the distance is same. By reversing these things, the distance will not change. That is why we are saying symmetry. That means dij is equals to dji. The values are still same. The distance are still same. Our fourth property is uh, triangular inequality. I think you guys know what is equality and what is inequality. So here we are talking about inequality. Triangular inequality. That means Dij plus uh Dij also Dj I is greater than Dik. Hmm. Wait. Triangular. Let me create a triangle here first. Ijk. So we have to inequality Dij or J. Sorry, Ij or Ik. Or you can also say JK. So what triangular inequality is? You can see this diagram. We have a triangle here. We have three different points I, J, and K. If we try to calculate two different records into a one, here we can see Dij. If we try to calculate the distance between Dij and Ik, this one, if we try to add them into a one, that means it is also greater than djk. If we try to calculate distance between this point j and k, two different records, when we try to calculate two different records into a one, like try to add them into a one, it is also greater to any other third record. If we try to calculate in triangle inequality, that means if we try to calculate a distance of square, that means four records. Sorry, let me make here. If we try to calculate I, J, K, and L, the distance here is same. All of points distance are little bit same, but if we try to like add two different uh, distance here, that means it is always greater than the third one, right? But here you can see, if we try to add I and J and K and L, it has some similarities. Like you can say it is also is equals to, like for example, these are I have one, 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 and one. The distance value is 1 1 1 for each record. So if we try to add them, so 2 and 2, these are same. So we can say D ij is equals to D K L. right? So this property is about triangle only. This is the another thing I have told you. This is the example I am telling you. But this property is very famous, triangular inequality, because whenever we try to add two different distances into a one, that is always a greater than third one in a triangle, right? So this thing is clear to you. What are these different four different equality, sorry, properties? Non-negative, dii is equals to 0, symmetry and triangle. So guys, that's it for today.